लास्ट लेक्चर मध्ये आपण एक महत्वाचा पॉइंट स्टेरिओकेमिस्ट्री या टॉपिक मध्ये डिस्कस केलेला होता. कन्फर्मेशन्स ऑफ सायक्लोहेक्सेन. देर आर टू मेन कन्फर्मेशन्स ऑफ सायक्लोहेक्सेन. वन इज कॉल्ड cheer and second is boat conformation. In addition to these main two conformation, there are two more conformation. One is a twist conformation and second is the half cheer conformation. Okay, this is just about the cyclohexane. हे झालं cyclohexane बद्दल. आता आपण बघणार आहोत यामधला पुढचा पॉइंट, कन्फर्मेशन्स अँड स्टॅबिलिटी ऑफ मोनोसब्स्टिट्यूटेड सायक्लोहेक्सेन. मोनोसब्स्टिट्यूटेड त्यामध्ये आपल्याला एक्झाम्पल बघायचं आहे. Methyl cyclohexane. This is methyl cyclohexane. This compound is monosubstituted. Now let us see different conformations of methyl cyclohexane. Methyl cyclohexane exists in a two form. It exists in a two conformation. Suppose this is the first conformation of methyl cyclohexane. This one is the first. Okay, this is the cheer conformation actually. It looks like cheer and here this is the methyl group. Then second one, this is again another form of the cheer. हा चेअरचा दुसरा फॉर्म आहे. म्हणजे या पहिल्या चेअरला फ्लिपिंग केलं आपण. हा कार्बन कुठे घेतलेला आहे, मी वर घेतला आणि इथला कार्बन जो आहे तो इथं खाली आणला, आपल्याला सेकंड फॉर्म मिळतो. ओके, these are the two different forms of that methyl cyclohexane. Both are cheer. The monosubstituted cyclohexane exists in a different cheer form. दोन वेगवेगळ्या cheer form मध्ये तो exist होतो. But in that two conformation, in that two cheer form, the positions of methyl group are different. The positions of methyl group are different. In first cases, methyl group is present at axial position. It is present at axial position, where in the second case, that methyl group is present at equatorial position. Okay, and thus in one cheer form, substituent group is present at axial position. Substituent means methyl group, while in other form, substituent is present at the equatorial position. These two isomers are having different energy and hence different stability. या दोन्ही कन्फर्मेशनची एनर्जी वेगळी आहे आणि म्हणून दोन्हीची स्टॅबिलिटी सुद्धा वेगळी आहे. ऍक्च्युअली बोथ आर चिअर, दोन्हीही चिअर आहे, बट दे आर हॅव्हिंग डिफरंट स्टॅबिलिटी. मग आपण या ठिकाणी स्टडी करणार आहोत वाय दॅट टू फॉर्म, दॅट टू चिअर फॉर्म आर हॅव्हिंग डिफरंट स्टॅबिलिटी. त्यांची स्टॅबिलिटी वेगळी का आहे? दॅट टू चिअर कन्फर्मेशन can be interconvert into one another by flipping of ring. That flipping of the ring can be takes place through the formation of boat. आणि मधली जी एक स्टेप असते त्यामध्ये बोट कन्फर्मेशन, but it is not stable. Stability खूप कमी आहे and therefore we are concentrating on the that two cheer conformation only. हे दोन cheer conformation फक्त आपण बघतो आहोत. ओके, आता एकामध्ये मिथिल ग्रुपची पोझिशन ऍक्सियल आहे. दिस इज कॉल्ड ऍक्सियल cheer. Axial form. This is called axial cheer form, and second is equatorial cheer form. It depends upon the position of substituent group. Is it axial or is it equatorial? On that basis, there are two conformation. One is the axial cheer and second is the equatorial cheer. Okay, let us see in detail first about the axial isomer. Okay, this is our axial isomer. Here the position of this methyl group. In this case, the position of methyl group is axial. Suppose this carbon is always numbered as 1, then 2, suppose 3, 4, 5, and 6. Okay, these are the positions of different carbon present in the cyclohexane. Okay, now the hydrogen atoms of C3 and C5. This C3 carbon and C5, that hydrogen atoms, they are also present at axial position. And they also present in the same plane. एकाच प्रतलामध्ये सुद्धा आहेत. म्हणजे हे दोन हायड्रोजन आणि हा मिथिल ग्रुप, they are present axially, axial position आहे, and also lies in the same plane. आणि त्याचबरोबर एकाच प्रतलामध्ये सुद्धा आहे. Here, that axial hydrogen atoms of C3 and C5, they are close to the methyl group. And therefore, interactions are developed in between that methyl group and hydrogen. And these interactions are called as the 1,3 diaxial interactions. That interaction, that non-bonded interactions are called 1,3 diaxial interaction. म्हणजे हा मिथिल ग्रुप आणि C3 आणि C5 यावरती असणारे हे दोन हायड्रोजन they are lies in a single plane, एकाच प्रतलामध्ये आहेत, they are axial, म्हणून काय होतं, they are close to the each other, one methyl group and that two hydrogen from C3 and C5, they are close to each other, means there is a overcrowding at axial position, म्हणून axial position ला एकाच प्लेन मध्ये overcrowding होते, and this is called non-bonded. Actually these are the non-bonded interactions, and that interactions are called as the 1,3 diaxial interaction. Due to this 1,3 diaxial interaction, axial form have more steric strain, म्हणून त्यामध्ये steric strain जास्त आहे, steric hindrance आहे, steric strain जास्त आहे, and so it is less stable and least preferred conformation than equatorial. It is having only 5% contribution. It having only 5%, and thus methyl cyclohexane exists only 5% in axial conformation. Let us see second. यामध्ये second बघूया, equatorial isomer. याला आपण equatorial का म्हटलं? Because methyl group is present at equatorial position. But what's about the C3 and C5? Okay, this is the C3 and this is the C5 carbon. What's about that hydrogen atoms? But in the case of this equatorial isomer, that methyl group and hydrogen atoms on C3 and C5, they are away from each other. They are apart from each other. Therefore, there is no 1,3 diaxial interaction. म्हणजे there is no 1,3 diaxial interaction and have less steric strain, and thus it is more stable and most preferred conformation. In axial conformation, methyl group at axial position and hydrogen atoms of C3 and C5 which are at axial position, they are close to each other. There is 1,3 diaxial interaction. There is a steric strain and hence it is less stable. But in the case of equatorial मध्ये मी दोन्हीचे comparison करतो. But in the case of equatorial isomer, that methyl group which is present at equatorial position, hydrogen atoms which are present at equatorial position, they are not close to each other. They are present in different plane, आणि म्हणून त्यामध्ये interaction नाहीये. Hence there is a less steric strain आणि म्हणून तो more stable आहे. It is most preferred conformation and near about 90%. It exists in 90% contribution. Okay, we can show by using that figure also, potential energy curve also. Okay, suppose this is the E for equatorial methyl cyclohexane, equatorial isomer, and this is the A. This is nothing but the axial isomer. Suppose equatorial isomer having less energy, सर्वात कमी energy आहे, म्हणजे energy कमी, stability जास्त, and it converts into that axial form मध्ये, आणि axial form जो आहे आणि इक्वेटोरियल फॉर्म यामध्ये असणारा एनर्जी गॅप जो आहे, इट इज अबाउट 1.6 to 1.8, म्हणजे तो कमी आहे. कंपॅरेटिव्हली दॅट गॅप इज लेस 1.8, and thus energy difference between these two forms is near about 1.8. It is less than 1.8 kilocalorie per mole, and therefore at room temperature that two forms can be interconverted into one another, because energy gap is very less in between that axial and equatorial form, and therefore these two forms cannot be isolated. And yeah, those forms isolation is not possible. They cannot be isolated because they at room temperature they can be easily interconverted into one another. Okay, this is about the conformation and stability of methyl cyclohexane.